Let's graph a rational function, and in this case, it's negative x squared plus 2x over 3x minus 15. And again, we're not going to graph it in its fullness, right? We're not going to draw all the swoopy lines and everything, but we're going to get as close as we can with a computer, which is to draw all the key features. Okay, y-intercepts, x-intercepts, holes, all the asymptotes. And hopefully by the time all these key features on the graph are on the graph, you should be able to see how you connect the dots. So let's start off with a y-intercept. Remember, the way you find the y-intercept is you set x equal to 0, right? X equals 0. And if you look at this equation, see 3x becomes 0, x squared becomes 0, 2x becomes 0. It's just a bunch of zeros, except that 15. You get 0 over 15, which is just 0. So that means we have a y-intercept at the origin, at y equals 0 and x equals 0. So let's put that on here first. And remember, the way you would add a dot or an intercept onto this graph is using the solid filled in dot button. Okay, so now how about the x-intercepts? Well, for that you need this equation in factored form, and it's nearly there already. I would just write this as negative x times x minus 2, and the bottom is factored for us. Well, almost. 3 and x minus 5. Okay, double checking my numbers. Looks good. Always double check your factoring. If you're off there, the whole problem is going to be wrong. So x-intercepts, well, let's just keep using the same color. You can see there's a 0 right here. That's the x equals 0 one I already found. And then I have x equals 2 from that other factor, so I put that one right here. Okay, x-intercepts are now done. Is there a hole in the function? In this case, there is not. There's no factor on the top, which is also on the bottom. So that's a DNE, and I'm just not going to put it on the graph. If you have a problem that has a hole in it, you would use this button right here, the open circle, and you would find the XY locations of the hole and plot that on the graph, just like a point, except you're using this open circle indicator right there. Okay, moving on, we need a vertical asymptote, which is factors on the bottom, not on the top, and I see only one, right, the x minus 5. So that's going to be a vertical line right at x equals 5. And to do a vertical line, you would use this line button, and it'll give you a little cursor, and you click on 2 points, and 2 points make a line. Okay, so there's your vertical line. And now I need a horizontal asymptote. Well, remember, this thing is top heavy. That means there's a factor of x on top, which is greater than the bottom. I have x squared over x, or negative x squared over 3x, but the coefficients don't matter. Point is, when it's top heavy, this is a DNE. Okay, so that's another one we don't have to do. And now we get to the oblique asymptote. This is kind of a little bit of a harder part. You can use long division. I prefer synthetic division. So let's go through the synthetic division of this. 3x minus 5, or really, x minus 5, is my denominator. So I'm going to put that 5 right here, that root. And the coefficients on the top are negative 1x squared, 2x, plus 0. So just work through it. Negative 1, that becomes negative 5, that becomes negative 3. We don't care about the remainders. So I have negative x, negative 1x, minus 3. But because you have a factor of 3 as a leading coefficient on the bottom, you have to remember to divide this whole thing by 3. Okay, and that's going to give you negative 1/3 x minus 1. That's our actual equation for the oblique asymptote. So using this line button, okay, we're still clicked on that one, so that's good. I'm going to draw this line on the graph. And remember, you have to connect 2 points. So the way we'll do that is I'll just mark points that I will use to connect my line. I know that negative 1 is one of them, because if you plug in x equals 0, you get, 0 minus 1 equals negative 1. And the other way I'm going to do this is think about what is a negative 1/3 slope. Well, that's something that goes down 1 and over 3. So down 1 and over 3 gets me to this point, and that'll be my second spot. So that's how you would mentally think about this. And then you connect those two dots using the little line thingy on the graph, and there's your other asymptote. Okay, so this one's done.